So for those of you who don't know, I'm Lucas Fiddle, founder and CEO of pganalyze. I'm also, an enthusiast of all kinds of Postgres. And so today we're going to talk about how to run Postgres on AWS effectively, basically the things that are new in AWS that relate to Postgres. We're going to talk about RDS, we're going to talk about Aurora, and we're going to talk about other ways of running Postgres using the CloudNativePG operator. This, comes basically from me just, observing what AWS is doing. So I have no internal knowledge. This is all public information. But certainly, it is something that I think might be hard to find sometimes because you have to go to the right session at reInvent, or you have to, read the documentation in detail. And so my goal today is basically just to share this knowledge with you. And then towards the end, I'll also tell you a little bit about how pganalyze can help you integrate with RDS and Aurora if you're not yet using pganalyze today and you're interested. Also, just so you know, if you have questions during the webinar today, please use the Zoom Q&A feature. I'll see those pop up as they come in, but we'll probably cover most of these questions towards the end. We'll probably have 45 minutes worth of content, and then we'll have some time for Q&A at the end. All right, well, let's dive in. So things I basically want to talk to you about today is I want to talk a little bit about Amazon RDS, Aurora versus CloudNativePG, just kind of, the three contenders today, basically, that I want to talk about. I then will mention a little bit about, just for background knowledge, about how, I/O differs in these different systems. This is just if you're not familiar with some of these internals and you may be making a decision between Aurora or RDS. Sometimes, we see the big headlines like Aurora is this much faster or this much cheaper, more expensive, whatever, like we see the top line things. But really, it's, I think, important to understand how the internal mechanisms work so that we can make a, smart decision about which one to choose, and then also how to scale their applications on RDS, Aurora, or other systems. I'll then talk a little bit about Aurora tiered caching, which is technically not a new thing, but I feel like it's become more talked about. Like this was first released in 2023, but it's become more talked about and it's more practical to use these days. Then I'll talk about Aurora Serverless V2 platform version 3. Very confusing terminology there. But basically, this is something that is new with Aurora Serverless and will help you, kind of if you're using that. And then I want to zoom out a little bit and I want to do a comparison between, if I'm making a choice, or maybe also if I've made a choice, right? Like what are the trade-offs here in terms of extensibility, right? Like how can I extend RDS Aurora today versus how, can I extend CloudNativePG, for example, and Postgres and CloudNativePG. And then talking about debuggability, community support, monitoring, a topic that's very dear to my heart, and then about the new Database Insights feature on CloudWatch, and then also how pganalyze compares to that. And then last but not least, closing with the new Database Savings Plans, which they're just a great improvement. Like, sometimes AWS just does stuff that's actually, just useful and good. Like there's nothing else to be said about it. I'll just give you some additional thoughts on, kind of when to choose that versus reserved instances. All right. So just, so we can clarify the terms that I'm using here today. So when I say RDS, I of course mean the relational database service that, exists in Amazon Web Services. So if you're somewhere else in the cloud, if you're using, Azure or GCP, they obviously have similar services, but we'll use a lot of specific AWS terminology today. But some of these, content does translate, right? So Aurora has equivalents in GCP with LLDB, has now on Azure there's HorizonDB. So they all kind of have their own versions of what Aurora does, but anything I'm talking about today is really specific to Aurora. And also when we talk about RDS, we actually do not mean Aurora here, just for clarity, because RDS used to mean both the regular RDS and Aurora, and AWS has, I think, tried to carve this out more clearly. Even in documentation now, it says, this documentation is for RDS, not for Aurora. And so just to be clear, when on a slide I say RDS, I actually mean not Aurora. And when I say Aurora, I mean, the actual, kind of custom version of Postgres that AWS has built in Aurora. And then if you're not familiar with CloudNativePG or CNPG, this is basically a totally different way of running Postgres in the cloud, where we're using Kubernetes cluster to host, our Postgres workload and our application workload, most likely. And then CNPG or CloudNativePG is basically a way to orchestrate that Postgres running in containers, right? So it's what I would say today, like, if you asked me 2 years ago, I would probably have said, look at the crunchy operator. But I think the reality today is that CloudNativePG has seen so much, development and so much community interest, and has really proven that I think they are now, the respectable default choice, basically. And I've heard of people successfully deploying in production as well, multiple times. So this is the choice to do if you want to run Postgres and Kubernetes. There's a fourth choice that I'm not going to talk about today, which is to run Postgres in a virtual machine. Obviously, many people run Postgres in virtual machines today. There's all kinds of trade-offs to consider there. But I think one of the things that's appealing with CloudNativePG and CNPG is that it manages failover for you, right? So if your Kubernetes cluster, for example, spans multiple availability zones, you can have CNPG orchestrate failover. So you're kind of closer to the managed experience that RDS and Aurora can provide. And so I think for today, that's why I'm kind of zooming in on that versus, a virtual machine-based deployment. Also, when I set out to put together this webinar, I was like, let me do lots of spreadsheets for cost comparisons. But the reality is it's actually really complicated. So I was kind of like, can I give you good actual, cost breakdowns? And I think the reality is you should really just make this math yourself, right? So this is math that somebody on the Vantage blog did, where, in this case, they said, RDS is 17% less expensive than Aurora. This math kind of, changes a little bit, but I think the core, thing that holds true is if you're optimizing for cost, CNPG, like CloudNativePG or Postgres in the VM is always going to be cheapest, right? We'll talk about database savings plan at the very end, but just one preview here is that you're going to get better savings out of compute savings plans than out of database savings plans, right? So AWS is always going to charge you a premium for using RDS and a higher premium for using Aurora. And so I want to highlight to you some of the functionality that might make you want to go the Aurora route. But really, if you're just optimizing for, what's the cheapest way to get a certain amount of CPUs and a certain amount of RAM, well, you should not use RDS or Aurora. It's always going to be more expensive, right? Is it going to be twice as expensive? No, it's probably going to be, 25%, 50% more expensive, depending on the specific configurations you use. Let's talk about I/O, because I think I/O is really one of these key things that is different between these different, implementations. And there's also a lot of things going on the Postgres upstream side, right? So like you might have seen me talk on the Postgres 18 webinar recently about asynchronous I/O. And so a lot of these things, I think are about to change in regular Postgres, but let's maybe just do a quick recap of, how we should think about caching and how we should think about I/O in Postgres. So regular Postgres, right? I have a client. The client will talk to a connection. The connection basically, accesses the Postgres buffer cache. And then in regular Postgres, you also have the OS page cache. Now, one of the things to know about is that Aurora does not have this OS page cache, right? So this double buffering that we oftentimes talk about with Postgres is only present in regular Postgres, as you might run in CloudNativePG, RDS, because that's just regular Postgres. Still, it's managed, but it's regular Postgres. Versus in Aurora, they have a totally different way of basically accessing the data directory. And so that's why the OS page cache, just double buffering, doesn't actually matter there. Now, share buffers, just as a quick recap, right? Like that's that internal mechanism in Postgres, manages buffers in certain ways. I'll skip over some of the details here. Like we have a full webinar that talked about this in the past. But the point is there's, this mechanism in Postgres that basically is used both for caching reads, but it's also used for writes, right? And so one of the things to remember basically is that how persistence works, right? Like there's a very particular way how Postgres does this and how Postgres interacts with the wall. And this still exists in Aurora, right? So Aurora still has shared buffers, but some of the mechanisms, for example, when we persist things to the wall and even persisting into the data directory, those things are very different on Aurora. Now, let me actually skip over this. One of the other things to know about is that there are background processes in Postgres, right? So we have, for example, a background writer. Background writer basically clears out kind of data that's in cache that's not yet written to disk. These mechanisms actually do also exist on Aurora, right? So this is not, something that you can stop thinking about. Like you actually have to think about these processes in Aurora as well. So stuff like tuning the background writer is still relevant. Now, when we talk about kind of, persisting, the other thing to know about is that Postgres has this mechanism, where we write stuff to the wall files, right? Now, on Aurora, that doesn't exist in the exact same way, but Aurora still has mechanisms to cache the information you're writing out, right? So it's still worth thinking about, am I contending kind of am I making Aurora very busy, for example, with, writing things out? Let me actually switch over here. The other thing to know about is what you should think about on I/O and Postgres in general is what's called synchronous commit, right? So synchronous commit basically controls if you're waiting for Postgres to flush things to disk, and if you're turning this off, you'll get better performance. This applies consistently throughout, RDS, Aurora, and CNPG. If you are okay with, losing data, then but not corrupting data, then synchronous commit off can give you a nice I/O boost. All right, let's skip ahead a little bit here. And my apologies. There we go. This is the slide I was going to. So let's talk for a moment about what Aurora does differently, because I think that's really the key thing to remember, right? So when I have a page I'm changing in Postgres, right, I'm making a modification, I have this middle step where I need to write out things to the wall. Now in Aurora, that's what's called the log write, right? So it's basically writing not to a regular wall file, but it's actually writing to this internal storage service. And then Aurora has, this kind of famous thing where behind the scenes, they're writing out 4 copies, at least 4 copies out of, 6 kind of possible copies behind the scenes, and then they return and basically say it's done, right? So the reason I mentioned synchronous commit is because synchronous commit does actually relate to this background, kind of persistence, right? So if you turned off synchronous commit, well, you wouldn't wait on this log write, basically. And so the other thing worth remembering about Aurora is that Aurora still has replication lag, right? So this internal mechanism with the log writes, like in regular Postgres, we have replication using the wall stream. We have, kind of connections between the servers. In Aurora, that happens through that background process, through kind of this log shipping mechanism. But you still have a delay from, kind of a write happening to the replicas actually being refreshed. What does that mean in practice? So in practice, when we think about Aurora, we have a system that behaves like Postgres, right? Like the wall, you still have to think about the wall. It's just that some of the specifics around which guarantees I have, like how fast something, gets flushed to disk change a little bit. And then the other thing to know about, right, is like in Aurora, I get a much better reliability story because I have these, kind of 4 copies on the storage side, versus in regular Postgres, including RDS and CloudNativePG, I basically rely on replicas to run to really give me that kind of resiliency that I can, on the Aurora side, rely more on the storage, right? So different mental model, but from a Postgres perspective, the application doesn't really care about that difference. The other things that are interesting about Aurora, and some of these things we're actually kind of getting towards this step where maybe this works on regular Postgres as well in certain cases for the first part. So the first term here is what's called full page writes. And again, I'm going to not go into the full details, but just a quick summary is a full page write is basically a mechanism that Postgres uses to avoid what's called torn pages. So when you have an 8 kilobyte Postgres page, there's a risk that basically when you have a crash, that it gets half a page and it gets corrupted data. And so full page write is basically a mechanism that Postgres uses between checkpoints to make sure that it actually can recover successfully, right? And then it can actually not have corrupted data. Now, Aurora can guarantee through different internal mechanisms that won't happen. There won't be any torn pages. And so Aurora basically does not have this full page write problem. That means that if you're looking at a regular Postgres wall stream, full page writes are in the wall, you will see more overhead, right? Because a regular Postgres wall basically has to write these full pages into the wall stream, versus Aurora does not, and Aurora does not need to do log shipping. So that will save you a bunch of things. Now, this may be possible in certain conditions outside of Aurora. On Azure, actually, Microsoft recently announced that they can now guarantee that there are no torn pages in certain cases. It's basically giving you enough, assurances that the storage will always write the full page and not half a page. And so, we may actually get to a point where this can be turned off across the board. I think we're not there today, right? So if you're on regular RDS, you will have full page writes enabled. The other thing to know about Aurora is that it doesn't have checkpoints. And this basically relates to, this internal checkpointing mechanism in Postgres really, doesn't translate to what Aurora is doing with the wall. And so that's why they basically heavily modified the checkpointer process in Postgres. And that means if you're thinking about, tuning checkpoints in Postgres, right, and you think about wall versus xlog versus time-based checkpoints, that doesn't really translate to Aurora in the same way. The other thing I want to mention, though, is Aurora is not always better, right? Like when we listen to AWS talk about Aurora, they'll tell you lots of good things, and I think it is genuinely impressive technology, and it's actually really good these days. But it is worth remembering that it's not always better. The first claim here, I'll get back to in a second, because there is a little bit of a change that was made recently there with what's called I/O optimized instances. So you don't necessarily pay for read and write IOPS all the time, but in standard Aurora, that's still true, right? So if you're using a standard Aurora instance, you will pay per IOPS. Now, IOPS are charged per full pages. They will usually be a little bit slower. This is something where you should basically do your own benchmarks, but just the internal overheads that Aurora has are a little bit higher than a regular disk, basically. Write IOs are always stored, always charged per that minimum size of the lock record, and then also write IO with synchronous commit will be a little bit slower than a regular RDS, for example, because you were waiting for more internal synchronization, basically. These might be good trade-offs. It's just worth remembering, like if you do a like-for-like comparison, you might actually see that, if you did a really simple select statement, that actually is slightly slower on Aurora than it is in RDS, but it might still be a good trade-off overall. The other thing to know about, right, so we're paying in one way or the other, we're paying for IOPS, but we don't really have a choice of storage, right? So on regular RDS with EBS volumes, we can choose IOs like IO2 storage, GP3 storage, right? We have different ways of choosing storage. Whereas on Aurora, it's just one class of storage. And then the one choice you do have is of instance size, right? So larger instances will give you more IO bandwidth, basically, whereas the smaller instances will give you less bandwidth, so you'll see less IOPS. And so one of the things that people are still saying on Aurora, right? This is the Aurora's own documentation talks about, if you have unoptimized SQL queries, right, that will incur higher IO costs because it has to scan more pages internally. And so this is why we see, many people use pganalyze is because they're trying to, optimize their Aurora IO costs. And one of the ways of doing that is by, finding unoptimized SQL queries. Now, Aurora IO optimized is interesting because I think this is a good example of where AWS is good at listening to people, at least most of the time. And so I think what they saw basically is a lot of people, liking Aurora, but being really, kind of struck by the cost of IO, right? Like paying for individual IO operations. And so IO optimized, basically, they now recommend when your IO spending is 25% or more of your total database spend, then you should use IO optimized. IO optimized is a choice you make on a per instance basis. And basically what it does, this is from a good presentation that was at last week's reInvent that just, summarized some good things about Aurora. But basically you increase your compute cost, right? So you pay more per instance, you pay 30% more for the instance, and you more than double your storage costs that you pay for. But what you don't pay for is IO, right? So basically what they're doing with IO optimized is it's kind of a combination of a different billing model, but then there's also some internal things that change. Like there's some subtleties in how IO optimized functions differently internally. But really the core thing to see here, right? Like imagine I pay for a terabyte of storage and I have very little IOs because most of it is cold data. Then I should actually stay on standard pricing, right? Like not IO optimized pricing, because I'm gonna not be having a lot of pay as use kind of IO. Versus if, let's say I have small, like 100 gigabyte volume, right? And I have a lot of IO, right? Like it's a lot of, kind of loading different parts of it. Then, IO optimized actually will be much better return on investment for me. You can switch between those two, but you have to do it within a 30-day window. Like you can't keep switching, right? Like you can't do this every day. Basically, the idea is that, you should pick one for each workload. And again, you can pick this on a per cluster basis. The other thing to know about, and I think this is interesting to me because I remember talking about something like this in previous life, like on how we can do caching better in Postgres, and how we can use on disk caches. So Aurora has something called Aurora tiered caching. And this is not completely new. So this is actually back from 2023. So it's 2 years old now. And they basically introduced this together with the optimized read functionality. So optimized read, just if you don't know about it, right, it's a feature that exists for both RDS and for Aurora. And optimized reads basically you can only use on instances that have local NMVE storage. And it basically like creates a hybrid of a local NMVE storage combined with the backing either EBS volume or the Aurora storage. And the goal here is that the local NMVE storage is always going to be so much faster than anything network based, right? There are some offerings in the market today that only use NMVE, right? If you go to PlanetScale or you go to Crunchy Data, they will sell you a Postgres on AWS that just uses the NMVE storage. That has downsides, right? Like mostly reliability downsides, but it is much faster. Now, Aurora and RDS don't offer that today, but what they do offer with optimized reads is basically a way to use that local instance NMVE storage to, have something that sits in between the memory and the disk, right? Because the disk network storage will always have a latency of, half a millisecond, a little bit more, a little bit less. Versus the memory and the NVMe drive, they will be much faster. And so with optimized reads, there's basically two things that they added to Aurora. So Aurora has what's called tiered caching, and then also a way to use the NVMe drive for temporary objects. When we say temporary objects, we mean temporary tables, we mean temp files, right? If you're doing a sort or hashing operation in a Postgres query execution, those are temporary objects. On RDS, we also have optimized reads, but RDS optimized reads only support temporary objects. That is much less interesting to me personally. I mean, to a certain extent, it's a little bit ridiculous that we are using EBS volumes to store temp files, right? Like that doesn't really make sense. So to a certain extent, I think, temporary objects should just be the standard, like it just makes sense. But I feel like tiered caching is actually something that can change the performance of your application drastically. So the way that this tiered caching mechanism works, again, only if you do optimized reads, is that you basically, what you have is you have, regular Aurora, right, like with the shared buffers, and then you have the Aurora storage. Now in the middle sits this NMVE storage. And so the NMVE storage basically acts as a mechanism, like if something is not in shared buffers, if it's not in the Postgres shared buffer cache, then instead of fetching it from the storage, it can be cached in this local NVMe storage. And Aurora basically makes sure that cache invalidation happens correctly, right? Because that's the hard part of this is like, you don't want to have this local cache grow stale. But think of it basically as an extension of memory. And so here in this example, it's basically 4 times the instance memory. There's different ways to influence the size of this. But basically think of it as, let's say you have, you're paying for 32 gigs of RAM on your instance. Well, you could have, 256, I don't know, 128 gigabytes of NVMe storage that basically, makes your RAM basically that much larger in a sense. It's worth noting you can actually do this yourself also. So I've previously successfully done this in a prototype, not a production workload, with DM cache on Linux. So there is a way to basically set up things so that Linux has a write-through cache and does this on a regular VM as well. So this is not necessarily novel in that sense. But what they are doing here is they're saying it works and we manage it for you, right? This again is from one of the read-my presentations, but here they basically show the latency, right? Like this is basically showing how on the right side we have the Aurora storage latency, whereas on the left side we have the memory latency. And so really what this instance storage can help us do, right, with the tiered cache is that it gives us, if you look at basically the the long tail of, there will always be stuff that has to be fetched from storage, right? But in this kind of like these are different workloads, different setups running. And so here with the yellow line, what they're basically showing is that the average response time, right, with the tiered cache in a picture, they get the average down to 0.35 milliseconds, versus if they have, a large workload and it's only, it's accessing the Aurora storage often, that can have up to 1.2 milliseconds, right? So you're basically paying almost a millisecond of penalty on the average here by having things go to the storage versus having that local instance storage and cache it. And that can make a big difference, right? Like if you have problems today with, your queries, like they're fast when stuff is in shared buffers, but they're slow when stuff, is not in the cache, basically. That's where that instance storage can actually really be a big difference between, your working set fitting into the memory and instance storage combined. The other thing that's curious about how this tiered caching works is that it basically, like I mentioned earlier, that I've implemented successfully on a virtual machine basis myself outside of Aurora in the past. Now you can do this, well, if you did it yourself, you wouldn't have this visibility. What they've actually done here is they've built this into the Aurora, storage driver basically itself, right? Like the part of the actual Postgres-like system. And so if you run an explain plan and you actually have this, optimized read cache enabled, you will actually see this in the plan as Aurora or OR cache, basically on each plan node where it does that access. Which is actually useful because it gives you visibility, right? Because if you're like, why is my IO fast in one case and slow in the other case? Well, in one case, the IO was fetching data from that local cache, which was very different than the Aurora storage, right? So this is something to look out for if you're using Aurora that can help you understand this caching behavior. All right, well, let's talk more about Aurora. So Aurora serverless. Horrible naming of this because I was like, is it V3? Is it not V3? No, it's V2. So there's no migrations happening between V1 and V2. Like there's no V3 you have to migrate to. But one thing AWS announced earlier this year was platform version 3. And so platform version 3 is basically you just get this automatically if you provision new serverless clusters in Aurora. And the main thing to know about it is that it basically offers faster startup times and faster spin down times. And basically, I think here they're talking about this as a performance improvement, but I found, again, this slide from one of the reInvent sessions more useful, where they're basically saying, it scales up faster. And then because it scales up faster, you have more time to, kind of run at the peak performance level, and then you scale down faster, right? So basically, this slide has MySQL, but the same applies to Postgres. Basically, the point is that on this new platform version, you will get, your serverless workloads reach the optimal kind of ACU count faster. Now, let's zoom out a little bit, right? So we talked a lot about Aurora, and Aurora is great, but what are the things that are not so great with Aurora, or why might we choose other options? So I think the topic of extensibility is quite interesting to me because it's kind of one of the things why, a lot of people said, you shouldn't use a managed service provider because you can't install extensions. And so I feel like it's kind of not true anymore because, like, I mean, it is and isn't true, right? So if you picked a commonly used extension today, let's say HypoPG, well, it turns out RDS, Aurora, and such, they have this available, right? But there are exceptions to this. So for example, if you were interested in using, PirateDB's PG search, if you're interested in using Citus, if you're interested in using TimescaleDB, these kind of more, complex value add extensions are not available on RDS and Aurora. They probably never will be, right? Like it's a licensing problem ultimately. Like, I mean, Citus is HEPL licensed, Timescale has a more restrictive license. There's not enough incentive, like Citus, the equivalent of that would be Aurora limitless. Like they basically built their own version. And so if you are, looking to use these extensions, I don't think that will change anytime soon. This is different with CloudNativePG, right? So one of the reasons you might be interested in using CloudNativePG in a Kubernetes cluster is because you can actually load custom extensions. And one of the things, again, CNPG development has been really rapid. Like there's like every month you check, there's new stuff. And so one of the things that they've added to Postgres 18 actually is that some of the CNPG authors work also on Postgres features upstream. And so one of the things they added was the new extension control path mechanism in Postgres 18. Now what they did this because now what they can do is if you have a running Postgres in Kubernetes with CNPG, you can actually add extensions dynamically at runtime to a running cluster without basically having to swap out the image, right? Because it's a container image. And so, well, if you have a new extension file, one way of doing this is you could replace the container image, but that's kind of inconvenient. And so what CNPG now allows you to do in recent releases is you can just, like make your own kind of extra image that you're loading, as a sidecar of sorts, basically as a side volume of sorts, that you're adding to your main kind of Postgres image. And so if extensions are important to you, but you want to have kind of this, level of manageability still, I think CNPG's approach to extensions is really interesting. And I think that, has a lot of promise, basically. RDS and Aurora have tried to make it more extensible, right? So, I want to give credit to the teams in trying. So trusted language extensions is a feature that has existed for multiple years now. It's basically trying to give more, well, Postgres extension mechanism has, some of these things are complex things like PostGIS or Citus or timescale, but there's also a way to use Postgres extensions to just package schema and function things together, right? So you might just have a PLPG SQL function you want to create on every one of your databases. Maybe it's your, helpers that you want to have always. And so TLE is pretty useful for that, right? So TLE is basically a way to use Postgres extension mechanism with very basic, simple extensions. They tried adding more hooks to this and making a way to actually hook into, core Postgres functionality. And this is where a lot of the interesting extensions rely on hooks, right? Like without hooks, you can't really do anything interesting in Postgres. Unfortunately, this has been, 3-4 years now. The only hook that they offer still is the pass check hook, right? So you can hook into, password checking, but that's about it. There's about, I don't know, 20, 30 other hooks that are interesting, right? Like you want to hook into the planner, you want to hook into, various activities in Postgres. And that's all not possible with TLE. And so that kind of means it's not possible to write any complex extensions with this TLE mechanism. Also worth knowing about is, we talk about more complex extensions. So if you wrote your own C extension, you can't load that into Aurora RDS, right? There's no mechanism for that. But RDS added support for PL Rust a couple of years ago. That doesn't exist in Aurora. I'm slightly concerned, to be honest, that I've not seen a lot of good use cases for this. Like, I don't know if this has, longevity, basically. I think Rust is really interesting to make Postgres extensible. There's a PGRX project that is used here for PL Rust as well, which basically lets you, write Rust code for your functions, which you could then use in an extension as well. But the reality, I think, is that this is a little bit of a maintenance nightmare, I think, for a managed service provider. And so I don't know if I would trust this, to always be around, basically. All right. The other thing that I think is worth thinking about when if you make a choice with your engine, you may not have a choice, right? You might have already made this choice. But if you're thinking about, should I be using Aurora RDS or CloudNativePG or some other mechanism, I think it's worth thinking about how debuggable your database is and if you're likely to get community support. So one of the things that I keep seeing in the community, like in the Postgres community, is that people are saying Aurora is not Postgres. And I think they're right to a certain extent. I feel like Aurora is a heavily modified Postgres. You might even strike too heavily. It really depends on what you're looking for. A lot of Postgres' behaviors are very similar in Aurora, right? The planner is the same, query execution is, the planner is mostly the same, query execution is mostly the same. Once it gets to storage, that's where it really breaks down. This is just, me taking a sampling of, the community Slack. Like, this is all public kind of archives, basically. But like, these are just community members where people have asked for help, right? Like, there's somebody posting on a Postgres Slack and being like, hey, I have this problem. And, here's like folks in the Postgres community that, I respect. And they're like, well, I don't know about Aurora. It looks like commit latency is jumping. It's not clear if Aurora has group commit. Maybe there's a separate limit, right? So people might just not know Aurora. People might not know the terms relating to Aurora. And sometimes people flat out refuse, to help with Aurora problems because they're basically saying, well, you're asking us, the community that works on the upstream Postgres, you should talk to AWS, right? And sometimes that experience isn't so great either when you talk to AWS, right? So it really depends on who you are and if you have a TAM assigned and such. But for example, here was somebody saying, we've reached out to AWS support about a slow blue-green upgrade, and we've basically been told to just wait and let it run. And it's been running for, 48 to 72 hours in one other example. So like you have much less control and you may or may not have a good experience with AWS support. I think they have some really talented people, but there's many more customers that need help than the talented people that they have. And so I think it will be hit and miss sometimes. The other thing that's sometimes concerning to me a little bit is that Aurora, there's lots of talented people working on Aurora at AWS, but the Aurora team itself doesn't really upstream functionality, right? There's a separate team in AWS that does Postgres contributions, which is great. Like, I'm really glad AWS does Postgres contributions these days and funds the upstream work. But that team is very separate from the Aurora team. And so one of the problems is that you see novel functionality showing up in Aurora that is not Postgres functionality. And so you might see surprising behaviors that basically only AWS can help you with. One example of this is Aurora recently added a new feature called adaptive joins that's in preview. It's probably not something, I don't have any first-hand experience using it. In principle, this is great, right? So what they did here is they said, well, oftentimes really bad query plans are when a nested loop join gets chosen instead of a hash join, right? Like we shouldn't use the bad join type. And so adaptive joins are basically a way to switch over from a nested loop join to a hash join at runtime. This is great. Other database engines have behaviors like this too. I think it's great that Aurora added this. From what I've seen, I don't think anybody from the Aurora team has tried to upstream this in Postgres, right? Like they basically built this into Aurora, but Postgres itself, whilst there were some discussions on implementing this, I've not seen any patch or anything that, would point to this being upstreamed into regular Postgres, which means that you basically have divergent behavior between Aurora Planner and Postgres, like regular Postgres Planner, which for the community, again, is hard to maintain, right? Like if somebody comes in and asks about a weird join behavior, like you don't really know what's going on. So the other thing that I've run into practically on both RDS and Aurora is that they don't let you run what's called a perf profile. So perf is a Linux tracing tool, basically, and there's a Postgres wiki page that walks through how to use it, but what it helps you do is it helps you investigate CPU overhead, basically. So if your Postgres database, has high CPU overhead, you want to know what's going on. Perf is really the best, way to get this data. There's just two samples on the right side of the Postgres performance mailing list where somebody, kind of reported basically issues, and then, the perf profile was what pointed into which part of Postgres is the problem, right? The middle report, the planning performance problem, that was actually somebody who was working for AWS who, investigated something. So if you are at AWS and you are an engineer, you can run this on database. But if you're a customer, you cannot, right? And so you might run into finicky Postgres problems where your only way out is basically to get support, to involve the product team, to involve the engineer who can actually run the perf report, because you as a customer cannot. Versus if you run on your own CMPG or virtual machine, you can run perf profile. So worth remembering that this, definitely makes a difference in certain edge cases. All right, well, let's talk a little bit about monitoring, because there's some new things with Database Insights, and also I think I'm really interested in monitoring myself. So I want to mention a few things. So first of all, from our perspective, right, like with pganalyze, what we found is that Aurora just behaves like regular Postgres for the most part, right? Like I can get all the Postgres stats views, I can get the query monitoring extensions like PG stat statements, auto explain. So these things work very similarly. So if you're working on optimizing query performance, either using a tool or just by yourself, a lot of the functionality is very similar. The same holds true for, auto vacuum monitoring or internal stats tables that, track how many shared buffer hits have you had. Like all this stuff is pretty much the same. One of the things that is more recent that I have an interest in is on plan statistics. And there was a question just now, if the slide deck or recording will be made available, you will get a email tomorrow with both the slide deck and the recording. So if you're like, do we need to take notes? No, you do not have to take notes. We'll send it over to you tomorrow with some additional reference materials. So plan statistics. Aurora has a thing called Aurora Plan Stats. And Aurora Plan Stats, sorry, Stat Plans. Mixed up the slide there. Stat plans. Aurora Stat Plans basically tracks which queries have run how often and with which query plan, right? So if I want to know, did my query get slower because a plan regression occurred, I can use Aurora Stat Plans to find that out. And this is really cool because it's the first time, like this was released, I think, let's see, a year ago. So this was released a year ago. And I think it was the first time that this was basically available in a production-ready way so that I can actually see, kind of good data points on plan regressions. So Aurora Step Plans is great. You should look at it, see if you want to enable it. What we did at pganalyze a year ago when this was released, we basically integrated this into pganalyze when you use Aurora. So what this lets you do, basically lets you show, for a given query, which plan is being used and how often and how does the performance differ between those different query plans. So this is great, but let's see. The downside is that they didn't release it as open source, of course, right? So as mentioned, Aurora team separate from the open source team. Aurora team doesn't really do much open source. And so at pganalyze, we said, well, we want to have this available more broadly, right? Like outside of Aurora. And so what I worked on together with a colleague early this year was what we call pgstat plans. And pgstat plans is basically a way to do the same plan tracking mechanism just as an open source extension. Right. This is available today. It works for Postgres 16, 17, and 18. Full feature set is available on Postgres 18. You cannot use this in RDS yet, right? Because RDS controls which extensions are installed, and they have not yet enabled this one. On Aurora, you don't really need it because you have Aurora stat plans. But if you're using, for example, CloudNativePG and you are running your own database, you could use this today to optimize, kind of capture the plan statistics. The other thing that I've run into, so as mentioned, the statistics used are basically the same except for plan statistics. The other thing I've run into is that there are different ways to get logs. And the one thing I'll tell you here, just because a lot of people don't know about it, is you don't actually need to pay for CloudWatch log exports if you know about it, right? So when you have a Postgres RDS or Aurora database, and you have where it shows kind of the choice you have when you provision it or when you modify it. It says, which logs do you want to publish? And you can choose, whether you want to publish the Postgres logs and some other secondary logs. And so for a database that we maintain on a regular RDS, for a single instance, just checking this little checkbox costs us $490 in, I think, October this year. Just because CloudWatch logs is actually expensive, right? Like indexing things in CloudWatch logs costs money, and that may not make sense, right? It depends on your log volume, of course. But it's worth knowing that you do not need to use log exports. You can, in fact, use the RDS APIs directly to read logs, right? So if all you care about is doing some kind of log analysis in RDS or Aurora, you don't have to do the log exports. You can actually access the REST APIs directly. They, access the files that are stored on disk on database server. You can configure that retention. Usually it's, I think, 7 days. But basically, this is something that is available for free that, has some rate limits, but it works well in practice. And so in fact, we've actually built what we call pganalyze log insights with these RDS and Aurora APIs, right? So when you use log insights in pganalyze, you don't need to enable CloudWatch logs. We just pull all this data directly from the RDS APIs. Now, if you are using CloudNativePG, right, if you're running your Postgres and Kubernetes, this is a little bit different, right? So, and we've actually had some challenges there in the past making this work with pganalyze, but now this works well in current releases. But in a Kubernetes world, right, like what happens is the pod that are running Postgres, like the containers running Postgres, they just emit the logs to stand it out, basically. And then you have the Kubernetes host store these log files on the host. And then there are tools like FluentBit or Vector, which basically connect to the host and read the files and then send it to destinations, right? So in this case, destination could be pganalyze, could be something else, kind of your choice. What's nice about this is that you kind of get this streaming mechanism that, in RDS doesn't really exist. Like even CloudWatch, has some streaming mechanisms, but they don't really work as well. I feel like, this is actually much nicer in terms of flexibility because I can just route my logs to multiple tools or do some filtering based on, kind of FluentBit or Vector configuration. So this is pretty nice. It has some challenges in making it work sometimes, but I think the flexibility of this is much better than what you get with CloudWatch. And of course, this also works with pganalyze. So one of the things that we've recently invested some time in is basically making sure that you can use either Vector or FluentBit to send log data into pganalyze as well. Now let's talk a little bit more about tooling. So one of the things I want to talk about is in RDS and Aurora, there is this built-in tool. There used to be this built-in tool called Performance Insights. Now, AWS basically announced that they're retiring Performance Insights to actually push back the retirement date that was originally planned for basically end of this year. It's now pushed back to June next year. There is no need to fear that retirement necessarily. So it sounds like a big thing, but they've basically just moved things under the CloudWatch team, under CloudWatch, what's now called CloudWatch Database Insights. And it's kind of interesting what they've done there. So I tried to summarize this in a blog post about a month ago because well, first of all, I talked to a bunch of people and they were confused what was happening. And then, it's just good. Like, even though, I have a vested interest in making people use pganalyze, I also want people, if they do a comparison, to understand what they're comparing with, right? And so this post I wrote here, which we'll include it in the resources tomorrow, I tried to do somewhat neutral comparison between what, was there in Performance Insights and is now in Database Insights. There's a couple of interesting features in Database Insights. So Database Insights, if you enable the advanced mode, has what's a fleet-wide overview. That's pretty cool. They also do actually now pull in the logs. So this does require CloudWatch logs. But if you just want to have more log information at a glance, that's now in Database Insights. And then they've made a bunch of changes that I think are a little bit hard to reason about. So let me walk you through them for a moment. So the first column here is Performance Insights. The second is Database Insights in what's called standard mode. The third one is Database Insights in the advanced mode. Now, if you want to have the closest to what you got previously, it doesn't really exist in the same way. Where that's most visible is on retention time. So Performance Insights previously, you could customize the retention time. You got like Performance Insights basically for free. And then if you wanted more retention time, you had to pay up for the extra retention time. Now in Database Insights, it's different. Database Insights, basically you either use the standard mode, which is like basically free again, if you ignore logs. Database Insights Advanced, on the other hand, that's charged separately, right? So you actually pay for that built-in monitoring tool. If you want extra retention time, you have to pay for the advanced mode. It's not customizable anymore with the regular standard mode. There's also a couple of things that only exist in advanced mode. Some of those have existed previously in the free Performance Insights tool and are now basically locked behind the advanced mode, most notably query plan statistics. So what I mentioned to you with the plan statistics, right, there's this extension Aurora. That extension, like the feature to pull that data, like if you want to use the built-in tool, that one basically now is only on the Database Insights Advanced mode. You can still query it directly, and tools like pganalyze can also use it. But if you are, kind of using Database Insights, then you have to pay for the advanced mode to get the plan statistics. And a couple of other things that, are basically locked behind advanced mode. So I think in practice, if you want something that actually has interesting features, you want the advanced mode. And then the thing to know about advanced mode is that it can actually get pretty expensive. So the way this works is it's a per vCPU charge. And if you think about, kind of how many vCPUs you have, and you may actually, if you think about Aurora, there are reasons to use larger instances because, I/O, for example, more I/O because you have a larger instance. So, for example, once you, get to 16 vCPUs, you're actually paying more than $100 per month per instance just for Database Insights Advanced. And then it gets, pretty expensive once you reach like 64 vCPUs. So this is worth knowing about. One of the things that, if you're interested in talking more about this, like we can also walk you through how pganalyze compares to Database Insights. We'll just show you a quick few slides now, but one of the things that we've seen people be interested in is, do I actually have to use Database Insights or can I just use pganalyze, which actually ends up being more cost effective. I talked to somebody recently who was basically, this is at volume, but they basically, with their large fleet size, they would have paid 5 times more with Database Insights Advanced than they pay with pganalyze. So we're investigating basically if this is the right choice to make. The other thing we're talking about here, I'll give you a really quick 3-minute pitch basically of why pganalyze is better than Database Insights, is that we've actually, well, obviously we've done this for a while. And one of the things that we, really always focus on is making sure that you can really drill down and you can see lots of details, right? So Database Insights it's reasonable, but like it kind of falls down in my experience when you drill down. So just one thing that I think really works well in pganalyze is, you have a query, you kind of see the query performance over time in pganalyze. You see the query plans over time. We see plan statistics, and then you can do plan comparison. This feature, we launched early this year, but we basically have, now a visual comparison of different query plans. And then we also have new functionality like pganalyze Query Advisor. So if you're interested in not just viewing the statistics, but also seeing how to optimize queries, Query Advisor helps you with that, gives you rewrite recommendations. pganalyze has Index Advisor, which gives you index recommendations. These are all features that Database Insights does not have today. Some of these things they've tried to do under DevOps Guru, but it feels like now it's all shifting towards agentic AI, and there isn't really an equivalent of this functionality in AWS tooling directly. And of course, we also have Vacuum Advisor, which works with Aurora and RDS. Now, all of that said, I don't want to pitch you too much. If you want to, learn more about pganalyze, there's a quick survey question at the end of this webinar. You can, set up a one-on-one demo. We can talk about all the features. I want to end with talking about database savings plans. So database savings plans, as mentioned in the beginning, are actually pretty cool because they're basically making it so that you don't have to use reserved instances anymore. So this was announced last week. The math to know about basically is that if you do reserved instance, right, no upfront, so you don't actually pay anything, you just commit to something. With reserved instances, you get between 22 and 35% of savings compared to the on-demand price. With database savings plans, you get 20% savings. They do claim some higher percentages, but if you look at the practical pricing information for RDS and Aurora, it's always 20% savings. So they also include, other non-Aurora, non-RDS databases in this. So, if you're DocumentDB, whatever, those have higher savings, but for databases in RDS and Aurora, it's 20% savings. It does not apply to storage charges, right? This only applies to the instances, but it does apply to IO optimized. So remember earlier how we said, if you use Aurora IO optimized, you don't pay IOPS, but you pay both an increased instance charge and an increased storage charge. For the increased instance charge, you do get these savings as well. And basically, they are a dollar-based commit, right? So they're not tied. Like what's really great about database savings plans is you don't have to choose what type of instance, what size of instance, or which region you're using in. It's just, you basically saying, I'm going to spend, $10,000 on my database per month, and I'm willing to commit to that for a year, which in practice for databases makes a lot of sense. Database savings plans still have slightly lower savings than compute savings plans for the same instances. So if you are considering using Postgres, basically deployed yourself, that will give you higher savings, right? With, the same size virtual machine. But still, this is a great improvement, right? Like basically, if you're running a database in AWS, there's no good reason not to use a database savings plan, at least for your production database, just because it's gonna, make a lot of sense. So that's all for today. Thank you so much for joining the webinar today. There's a few questions already that I'll get to now, and then if you have more questions, feel free to put them in the Q&A. As mentioned, we'll send over the resources tomorrow at the same time, roughly. So thank you so much for being here. And I'll take a sip of water, and then I'll get to the Q&A. All right. So Mahesh had a question on log storage, which was, I think, related to log monitoring. And the question was basically, will it be stored for 7 days or store it from each day to next? I'm not sure about the question exactly. I think it's related to, Mahesh, if I got you right, it's basically about do the log, like how does the log export work, and also how does this relate to the log files that are stored that I can access with the APIs. So maybe just to reiterate how this works, my understanding is if you enable the CloudWatch log export, that's basically a continuous log export, right? So when you tick that checkbox, that basically, like any new log event that happens, that one will be streamed out to kind of the CloudWatch logs environment. In parallel to that, you have the log files that you can change the retention time for, typically 7 days. Those are just stored on the database server. And so they don't really relate to each other. They happen independently. But the point is you can get the log data from RDS and Aurora without having to pay for log exports. And then Mauricio had a question. Can Aurora stat plans detect changes such as exact sync and CPU behavior changes between versions, or is it just timings, buffers, and regular explained data? So Aurora Stat Plans is really focused on query plan tracking, right? So think of it, if you're familiar with PG stat statements, which captures query statistics and tells you, for this query, how much runtime, how much IO was it doing? Like it gives you some like high level information, but it doesn't tell you, like for the runtime, it wouldn't break down where the runtime was spent, right? So if you're seeing wait events, for example, in exact sync, you wouldn't see that detail in stat statements, and you wouldn't see that detail in stat plans. Really, that's something where you have to look at wait event sampling, which kind of happens independently of that. So it's not really useful for that. It's really more useful for detecting plan regressions, I would say. And then Sai had a question for when we use pganalyze, does it collect the data from the Postgres log file? So the answer is yes, some of the data, right? So some of the information that pganalyze collects is from statistics tables, from pgstat statements, things like that. But then pganalyze also can capture query plans and plan samples, and those we capture from a log file. So it's kind of a mix of the two. If you're familiar with what, for example, in open source tools, there's pgbadger. We basically have a streaming version of pgbadger built into pganalyze for some of the data points. And then Daniel pointed out a good thing that I didn't mention, so I'll mention it now, which is that database savings plans are available for serverless, which is a big news because that's not available for RIs. And you're right, I forgot to mention that. So if you're using Aurora serverless, you weren't able to purchase reserved instances before, versus now with database savings plans, you can apply that commit to not just the provision instances, but also the serverless, which I think I'm really happy with database savings plans. I think it was ridiculous that it didn't exist, a couple of years ago, but it's great it exists today. All right. Let me see. Okay, so this is a question from pganalyze. Curtis asked, for SaaS companies that have many similar deployments for the same code base, do people typically install pganalyze everywhere or just in representative servers? It's a good question. I mean, it's kind of up to you, right? It's like pganalyze in multi-tenant environments. Some people only, like use it for the problematic tenants. Other people use it for everything. One thing I'll say is if you're, in the hundreds of instances, talk to us. Like we do volume discounts, things like that. Again, coming back to, is pganalyze more cost effective than database insights? It definitely is at scale, right? So I'm happy to talk through what makes sense, but you can also just do a subset. All right. Justin had a question on what are the practical limitations around using the AWS API for log consumption? Good question, right? So this talks about the RDS API to download log files. So there are some limitations worth knowing about. I would have to, look back at the actual code of how we implemented this. But basically, if you're interested in this, the pganalyze collector, which is the agent that pganalyze uses, does have some particular behaviors around getting the data from the RDS log APIs, and it streams them like using a log tail. One of the things that can be a problem, and I don't recall how CloudWatch handles it, is if there is too high of a volume in a given time frame. Like you don't want to pull these APIs all the time. And so they're like theoretically you might reach a limit where the log download API can't handle the volume and the CloudWatch log export could. But in practice, usually you don't want to do that anyway because the CloudWatch log export would end up being so expensive that it doesn't really make sense. But yeah, there are some things to think about in terms of how much log volume in a given 30-second window you create. Happy to follow up on this offline as well. Great. And then let's see, let's get to a few more questions. Thank you everybody for asking good questions. Sai had a question on, is pganalyze getting integrated with AI agents for performance and giving recommendations? So we don't have any news to share today. One of the things I'll mention though is we had a customer of ours, Robinhood, recently launched or internally built an MCP server, and they wrote a blog post about it. We can include it in the resources for your reference. But basically what they did is they used the pganalyze API to hook up an MCP server, and then they used that internally to help their developers basically be more productive by having AI tools query the MCP server, which would query the pganalyze APIs, which would give them production information without, unsafely accessing the production database. So there's lots of opportunity there for us to offer this as a built-in experience, which you'll see us do more of that next year. But yeah, if you're interested in this, feel free to let us know, and I'd be happy to follow up. All right, and we had a question on, can the RDS API access logs only until the enabled retention, or how can we get historical logs? That's correct. So the RDS API will not give you historical logs beyond the retention, right? Like they're actual physical log files. And so if you have like either, from a monitoring perspective or from a compliance perspective, you need to have access to older logs, then you do need to use something like CloudWatch logs or equivalents, right? So again, CloudWatch Logs is not the only way to do this. Like there's other third-party log monitoring tools. There's pganalyze. So this is something that could, kind of address that for you. But sometimes CloudWatch Logs is a reasonable choice, right? Like I'm just basically pointing out that you don't have to use it. But if you care about historical retention, it probably is the easiest way to get like a 30-day retention or 100-day retention, like to just pay for CloudWatch Logs. All right, and then there was a question on comparing pgTLE, which is the extensibility in RDS and Aurora, versus CloudNativePG extensibility. So the dynamic loading that we talked about for CNPG, that's only available in EKS. That's correct. Yeah. So well, EKS, not really. So it's CNPG, right? So the way to think about it is that they're very different mechanisms, right? So if you think about extending your database and extending Postgres, TLE is good for certain use cases, which are about, I have my schema objects, my functions that I want to create consistently. CNPG really supports the full breadth and depth of Postgres extensions. So if you wanted to, add a Citus or timescale DB, you could do that with CNPG versus you couldn't with TLE. Also, since I think you mentioned briefly about pganalyze, so pganalyze actually does not require extensions. So we do not rely on TLE or CNPG today at all. This is just, sharing this for kind of, if you're evaluating different solutions, what I found useful, but pganalyze itself does not require any of this. Let me see. Well, we'll maybe take 3 more minutes to answer a few more questions. We'll send the recordings. If you have to drop, feel free, but I'll get the rest of the questions since we are almost there. All right, let me see. There's one question I'll probably get to async on the kind of pganalyze and savings plans. There was a question around that Valid had around asking about reserved instances. So if you have reserved instances, can you still enable IO optimized and keep those savings? That's a great question. I don't actually know, to be honest. Right, so you're asking, like, if I have an Aurora instance right now where you use standard pricing and I go and enable IO optimized, will I lose my RI assignment, basically? Can I use the RI? I suspect they would let you keep using it. It would be kind of ridiculous if they would force you to, abandon your RI. But I don't know for sure. This is something that I would probably just ask AWS and confirm. This is where Database Savings Plan, take out the headache, right? But for RIs, I'm not sure. And then Ricardo had a question about pganalyze, like how pganalyze handles credentials when we log into a database. So we can support IAM authentication in RDS and Aurora. So that's, what's easiest probably to avoid, having passwords, but there's other ways of managing passwords too. If you have questions about that, happy to set up a direct conversation. All right, and then last question. This has a little longer details, so let me see if I get this correct. So Omar asked a question around a performance issue that Omar faced with 10,000 requests per second with an Aurora 16 ACU, so a serverless instance, where basically the requests per second were capped, and then if they ran the test twice, it got faster a second time. And so there seems to be a bottleneck around, kind of how fast it's scaling. And so basically they're saying, like, if I understand correctly, Omar, basically you're saying in the very beginning it was slow and then it ramped up. I would probably look at, so Aurora does have, like serverless does have graphs on kind of when it scales up. So I would probably, what I would do is I would go into the monitoring metrics basically, and I would confirm that you're scaling, like at which point your scaling was finished. I mean, this is where the platform version 3 that they announced this summer is supposedly much better, right? So basically this ramp up performance to full performance, full ACUs, that actually is much better now in the platform version 3. So if you provisioned this Aurora serverless cluster on an old platform version, it might be worth checking if you can upgrade that. That might make a difference here. But yeah, I would look at the internal metrics to understand that better. All right. Well, thank you everybody for joining and staying long. Appreciate it. And please reach out if you have any more questions.